Yeah, today we are going to discuss about data representation so that we get to understand how does a computer represent data, which data we feed into it, which sometimes comes in form of voice, it can be in form of videos, it can be in form of text, numbers, and so on. So we just need to understand how does this being represented in a computer. So we are going to look at data representation, number system, as well as the base conversions. Yeah, I have already talked about the human brain process of large variety of data, which can be in the form of the characters, can be in the form of numbers, images, sounds, touch, smell, and tastes. So you realize that today, uh, computers can manipulate numeric data in various ways, regardless of how complexity it might be. But computers are in position to do what? To convert it and interpret it. So data can be represented in various ways. One of it, and the most popular one, being the numeric format, which comes in three formats, that is binary, octal, as well as hexadecimal. You will excuse my voice, but I hope you are able to hear whatever I'm talking about. Those who are online, kindly, you can confirm through text, through what? You can confirm through text. Just send a message to confirm if you are able to hear my voice, so that we are sure that even those that will get the recording will be in position to hear it. Just send a text, it will be enough. Then okay, Irene, thank you so much for the feedback. Let us proceed. I was telling you that yeah, data can be represented in numeric data in the form of binary numbers, octal numbers, and hexadecimal numbers. Then we also have, we can also have, yeah, curious. Also, thanks for the feedback. We can also of late have what we call data representation, but in a non-numerical way. So data can also be represented in a non-numerical way. You get, and the various formats, various data formats have been formulated by different organizations, entities, and one of the formats that you can represent it, or data can be represented in, is the American Standard Code for Information Interchange, which is ASCII. Then we have another format, ABCDIC. Then there is also Unicode, you get. So we are also going to look at the number-based conversions in this very session. These ones, I believe, people will read it through and be able to understand. Now, let us look at the first way of representing data in a numeric way. And these are numeric data representations, which deals with the presentation of numbers in computers, whereby in digital computers, the most commonly used number systems are these three: the binary, the octal, as well as hexadecimal. You get, yeah, as you can see down here, we have number systems, its base, as well as how it is being used. Binary, you will understand. Binary is base 2, because the word by in most cases it means 2, and when you talk about decimal, we are referring to base 10. because the word decimal is like, you see, deci means, actually we have even words that have originated from deci. Excuse me. A word like a decade. Yeah, everyone knows the word decade. When you talk about decade, it means like 10 years have done what? Have passed. So now when you talk about decimal, it comes from deci, which is uh, a term or that is associated with what? With 10. So decimal is a base 10 system, meaning we have 10 different numbers in the decimal what? System. That is why you see here, if you can see my highlight, yeah, these numbers, if you write from 0, then 1, 2, 3, 4, like 1, 2, add 3, 4, 5, 6, 7, 8, and 9. So when you calculate, I mean, when you count these numbers, they are 10 what? They are 10 numbers because we started from 0. This is 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So they are 10 what? They are 10 numbers. This kind of system is what we use in what? In everyday counting. For example, you can say maybe 12 goats, 36 sheep, maybe 468 laptops and so on. So we use it in our day-to-day what? Counting. You get. For binary, just a brief one, please. Allow me to pause a bit. Yeah. Now, yeah, when you talk about the binary, I told you that computer stuff is easy to understand because now, like the word binary, you see that word by, let me just turn on my pen briefly. Yeah, the word by, you get, in most cases, you know that this means two, meaning that the binary is based two systems. This is so much used by computers, as you know very well that the computer can only and only understand numbers, which is zeros and ones. Yeah. And for binary, you realize that we have zeros and ones. So in most cases, zeros represent the off state. Then ones means the system is in an on state. So there is off and on. Zeros are off and then ones are on. You get. So then when we talk about the octo systems, this is like the octagon. If you know the octagon, uh, this is octagon is like a polygon with eight sides. So meaning that our octo number system is a base 8 what? System. The way you can calculate from 0 to 7, meaning that those are what? Those are eight numbers you get. So it is the base what? Base 8. The way how we have seen binary as base 2 and the decimal as what? Base 10. Then when we go to the hexadecimal, you get those like two words. Hexa, it is like a hexa, hexagon of six what? Six sides, like I have just uh, told you. And then hexa means the six, you get. Oh, a hex. A hexagon, of course, comes with the six sides. Then decimal, we add the 6 plus what? Plus decimal, which is base 10, to have the what? The 16.
Yeah, excuse me, sir.
Yes, please go on.
Yeah, good morning.
Morning, how are you?
Yeah, I'm fine, sir.
Mm.
Yeah, suppose a person is asked to define maybe binary number systems, then I come up with maybe saying that these are base two number systems. Am I right or I'm wrong? Maybe
Come,
when I'm
come,
giving an maybe for example,
come again. I didn't hear that.
yeah, I was saying that suppose a person is asked maybe to define what binary number systems are. Then I say that these are base two number systems. Am I correct or wrong?
You are completely perfect and right. Yes. Binary, they are just base number systems. The way how decimal are base 10, octal base 8, and hexadecimal base 16 number systems. You are right.
Okay, okay.
Now, for hexadecimal, as I was still telling you, it combines both the hexa as well as the decimal. And I have already told you that hexagon has 6 what? Sides, meaning that hexa is like the would be base 6, then the decimal, which we have already seen as base 10. So meaning that this hexa decimal is a base 16 number system, meaning that we are going to write or consider from 0 up to 9 to have the decimal, the way how we did when it came to what? To decimal number system. Then for us to get get the to get the 6 that are extra from the decimal, we shall obviously now be using uh, alphabets to represent 11 up to the position of 16. So meaning that in this case, we are going to have, let me read here, 0, where we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are already decimal places with the 10 positions. Now, since 10 has 2 positions, so we cannot consider it. So in this case, we shall now use, if we are to consider 10 here, we shall now consider 10 as A, 11 as B, 12 as C, 13 as D, 14 as E. So basically, we just need to count until we reach the 16 what? Position, which is, let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Very good. Yeah, because 9 is in the 10th position, so A represents 11, then B represents 12, C represents 13, D represents 14, E represents 15, and F represents what? 16. So that is what? That is the hexadecimal. Now I want us to at least carry out some conversions. Yeah, I want us to carry out some conversions whereby we have three number formats in a computer world, which is integer, the floating point, as well as the binary code decimal format, which I believe everyone will have to read and interpret. Let us do something here. Let us do something small here together. Let me use one, let me get one slide here that we can use. Let's say we are going to convert a decimal to binary. Decimal. Binary. We can use, you see there are ways of converting these numbers. We can use the subtraction method, or we can also use the successive division method.
Yeah.
Now, I always prefer to use something that is easy. Someone is not muted and it is returning noise. Kindly mute so that you don't disrupt the session. Robert, mute. Robert, mute. Yeah, thank you. Now, I want us to convert decimal to binary together. And I've told you that we can use two ways. We can use the subtraction method, or we can also use the successive division method. Now, let us get any number, something like, let me, let me get this. Maybe we can pick any number like 348, which is what? Which is a decimal number. Now, which is of course base what? Base 10. Now, we need to convert this into binary, and of which you know that binary uses zeros and what? And ones. You get? Yeah, because it is binary is base 2. You get? Now, how do we achieve this using the successive division method? What we are going to do is we are going to just keep dividing our decimal number by the excuse me. Yeah, so we are going to divide this maybe by 2, which is our binary. And when we divide this, obviously it will lead us to 174. Is it 174? I think so. So remainder what? Remainder 0. Now, then we shall carry this, meaning that we are now going to put 174, then we divide it by what? We divide it by 2, and we shall get, is it 87? I think 87, yes. 87, reminder what? 0. Then we carry this, and we say our 87. If we divide our 87 by our base 2, we shall end up going with the 43. Is it 43? Anyone with a calculator? Anyone with a calculator? Anyone with a calculator? Let me get a calculator briefly also so that we are able to calculate fast. Yeah, I was looking for a calculator. Now, when we say 87 divided by 2, obviously we get 43.5. Now, being that we are recording reminders in a binary format, 5, we cannot say, okay, the answer is 43.5, right? Now, how do we now convert this into binary? We have to take our our 5, we multiply it by the binary, which is 0.5. Kindly mute. Trust mute.
Haya.
0.5, when you multiply it by 2, you get 1, meaning that now our remainder here is what? Is 1. So then we remove this. So there we shall just take the 43. Now our 43, if we divide the 43, I know, yes, some people know how to do it, but now my interest is on those that don't know how to do this, so that they also do what? They also benefit in this. That is why I'm using the most basic way, so that, everyone is able to interpret this and do it on their own. So 43 divided by 2, we get 21. Of course, also 0.5. But being that we cannot record 5, so we shall multiply 5 by 2, 0.5 by 2, which will also give us a remainder, which will also give us what? 1. Then we shall carry our 21, which is 21. When we divide 21 by 2, 21 by 2, we shall get 10. Of course, also 0.5. If we get 10.5, then we shall carry our 0.5 times 2, which will also give us what? Give us 1. Then we shall proceed to carry our 10 divided by 2, which is 10 divided by our base 2, and it will give us what? It will give us 5. Remainder what? Remainder 0. Then we shall take our 5 divided by 2. 5 divided by 2. We shall obviously get 2.5, and we shall take our 0.5 times the base 2, and then it will give us a 1, which is now remainder 1. Then we shall now proceed and say to this one, the one we are moving now here. So 2 divided by 2, then it will obviously give us, when you say 2 divided by 2, you get what? 1, remainder what? 0. Okay. Then we pick this one, and say 1 divided by 2. Of course, you know that 1 is less than what? Less than 2. So in this case, obviously, we shall get a 0 and a remainder what? Which will be 0.5. So which is now a remainder what? 1. That is when you multiply 0.5 by 2, you get 1. So now this one, we only pick out, we only consider the what? The reminders we get. Yeah, we only consider the reminders in this case. From bottom, this is how we record it. From bottom here, going upwards, which is the most significant digit, and then going up here to going up to the least significant what? Digit. This is the least significant digit in our case. And then this is our most significant what? Digit. So meaning that we are going to have 348 will be equivalent to, now we are going to record it from bottom going up until we reach here. So we are going to have 1, 0, 1,
ino kintu kibadde simanyi nti erimu maanyi
0,
maanyi mubadde nze
1, 1,
sibali munda
0.
wasamye Julius
Treasure,
Robert
try to mute.
Serekabe.
So meaning that this is our what? This is our answer after converting our decimal, which is base 10, into our binary, which is base 2. That is why we are considering only zeros and what? And ones. You get? So to get the answer, just look at the what? The reminders. You get? So this will be the binary number in this case, which is equivalent to 340 what? 48. We read it from the bottom to the top. So we can also maybe now use or go to another what? Another example. Shall go to another example and say we are now going to convert. Let us try to convert the same decimal number into octal. Yeah, maybe people can understand more. Decimal. What? Octal number system. So we are going to use the same what? The same number. We can say 348. Which is our base what? It's 10 decimal. Now we want to convert it to what? To octal. Our octal, like we said, octal is base what? Is base 8. You get? So previously we were dividing.
That lecture is not serious. I think it's a yes. I agree. That lecture is not serious.
Bernard, like I told you members, this class is not mandatory. I'm just recording. You get, it is not a must that you have to be here. I'm just recording, but those who have time are the ones that are free to join and listen in, but it is not a must that people have to attend. You get, because today is a day, actually a public day for the university. It is a gazetted day for graduation. You get. So when you start complaining the lecture is not serious, I'm doing this just for your own good. You get. Yeah, I'm not saying you must be here. You can be here or you can even leave. You get. So try to uh, try to understand this. Yeah. Um, I don't know if you can see, if those who are live can still see my screen, the whiteboard. Okay. Now I want us to convert the same number, which is the 348, which is the base what? Base 10. I want us to convert it to what? To octal number system, which is base what? Base 8. You get. Yeah. Now, previously, when we are converting this decimal,
Excuse me, sir.
we have been dividing our number by what? By 2, because we are converting it to binary. But
Excuse
now,
me,
this
sir.
time around, we are going to convert this, by 8, because we are looking.
Excuse me, sir.
Yes, please. Matthias, go on.
Excuse me, sir.
Matthias, I can hear you. Go on.
Sir, we are just hearing what you are talking, but we are not seeing it. The screen is still searching
Oh,
for you.
oh, how about other people? Are you able to see, or you also don't?
Me, I'm able to see everything.
Matthias, you might be having issues with the network. Maybe you have to rejoin or something. Yeah, because other people are able to see. Now, what let us
Okay,
try
let me
to,
try again and I
yeah, try to rejoin. Maybe you are able to get a better experience. So meanwhile, let us let us use the same number, 348, which is our decimal, and this is base 10. We are going to convert it to what? To octal, and then we see how things move. So now, instead of dividing this by 2, we are going to be dividing this by what? By 8. And we just, the same format, because I told you are using the successive what? Division method. So we shall just keep doing what? Carrying the what? We shall keep carrying the reminders. So when you say 348 divided by 8, 348. We divide it by 8. We shall get something like 43. 43. Let me see, let me calculate it here. 348 divided by 8. Yes, you get what? You get the 43.5. Now, our 0.5, when we multiply the 0.5 times 8, 0.5 times 8, we get our remainder as what? Remainder as what? As 4. Yes. Then we get the 43 this time round, divide by 8. 43 divided by 8, we shall get 5.3 what? This is 5.375. Now, the 0.375 multiply it by our base 8, then it will give us a remainder what? Remainder 3. Then we carry our 5 divided by 8, of which, like we did the other time, on the other side, which is this one automatically is what? Is a 0. And remainder what? Remainder 5. So still we use the same method when we are recording it. We record it from down, from the most significant digit to the least significant what? Digit. So meaning that our 348 decimal place is equivalent to 5, 3, 534. You get? Yeah, over to 534. This is it. Base 8 from base 10. So that is how we can do this. Let me try to check. Okay, yeah, Robert says he's now able to see. Okay, yeah, no problem. Let us proceed to also try. Maybe we need also to try. We need to try and see how we can convert decimal into hexadecimal. If we can be done with those three number, I mean, those three formats, then at least we shall be good to go. Yeah. So now let's see how we can do this while using the base 16, which is the hexadecimal. Okay, let us proceed. The next one. Yeah, what I want us to do is now to try out converting decimal which is our deci. I don't know if you can still see what I'm trying to write on the whiteboard. Okay, thank you, Eric, for confirming. Yeah, we're going to convert decimal, which is base 10, to what? To hexadecimal, which is base what? 16. Yeah, but I want to emphasize that this is not a mandatory class. I'm just recording, this session, but those who have time are the ones that are preferred to join in, but it is not a must that, you have to be here. So feel free to interact the way you feel is convenient for you. Yeah. Now we are going to use the same number. We can use the same number. Maybe let us use the same number of 348. Yeah. Now 348. Yeah. Which is our decimal number, base 10. We are going to be looking for the base what? Base 16 equivalent of this. So meaning that this time around, we are going to still use the successive division method by dividing our decimal number by the base 16 that we need to convert it into. Yeah. So we are going to divide our 348 divide it by 16. It will give us, let me get it here briefly on my calc. 348 divided by 16, we get 21.75. You get? Now, we just multiply our 75 by our base to get the proper remainder. We multiply 0.75 times 16, we get 12, meaning that, yeah, we take the remainder of what? Of 12. Then we carry this, which is 21, divided by what? By 16. That gives us what? 21 divided by 16. We shall get 1 point what? 3125. So now to get the exact remainder, we get 3.3. It is 0.3125. Multiply it by 16, we get remainder 5. Then we carry this one, which is 1. And of course, you know, since it is less than 1, 16, so it will obviously returns a what? A 0, which is it's a 1. Excuse me. 1 divided by 16, you get 0.0625. 0.625, multiply it by 16, then obviously we get remainder what? Remainder 1. So meaning that we are going to take these what? Reminders. You get the usual way from down, from the most significant digit to the least significant digit, which means that our 348 base 10 is equivalent to 1, 5, 1, 5, 12. But it being that now we cannot record the 12 because it has two digits. So meaning now we go back to our hexadecimal and see which letter represents 12, because I told you hexadecimal is a base what? Base 16, meaning we count from 0, we go to 1 up to 9. Those are 10 what? 10 places. Then 11 is represented by what? A. Then 12 is represented by B. 13 is represented by C. 14 is represented by D. 15 is represented by E. And 16 represented by F. So now, for us, we are interested in 12, which letter represents what? 12. So this is 11, 12, which is C. 10, 11, 12. Then we carry our what? Our 12 in this case. So you realize that all what? All number conversions are what? Easy, and they are doable once you follow the what? The steps. So now what we are going to do is we are going to now try out on our own. How do we convert binary decimal? You get. And how do we convert? We can also try out for octal to binary, or binary to octal, or binary to hexadecimal. You get. So basically, what we are going to do is I'm going to maybe put something in the what? In our model, so that at your free time you are able to try out something, and then members, I don't want to make this a long session, so allow me to terminate from here, unless maybe you have a question, but I'm going to upload the content on your model, as well as a simple assignment that I need you to try out, yeah, after watching the clip. Otherwise, I wish you a nice day, and bye for now.